Right, notice how there's nothing to do on the denominator, it's already factored, right? It's not a trinomial, it's not a difference of squares, there's nothing in common. It's literally factored for you. But there is a repeated power, it's a power of 2, so this is a repeated linear factor. Okay, so this is case 2 in your notes. I'm going to pull up the notes real quick, the printout. That's weird. Oh, there it goes. Mhm. That is weird. Okay, I don't know. Okay, sorry. Adobe was being weird. Apparently, have too many devices. Whatever. Okay, so case 2. So we understand at this point, just a quick review. I hope that if you see 2 linear factors, or if you factor it and find 2 distinct linear factors, you just put A over the first one, B over the second, right? At this point, is everyone comfortable doing something like that? Is that okay? So case 2. Case 2 had case 1 and no, where is case 2? Sorry, went too far. Am I missing a page? I get messed up. Yeah, Adobe did mess. There we go. Okay, so case 2. Notice we had a 2 on a factor, right? The power of 2. So because of that, you have to do 1 and then 2. You have to count up until whatever power is on here. Okay. So we're gonna have a B over that and C over the other one. That's all we're gonna do. So back to our question. We're gonna have A over x minus 4 plus B over x minus 4 squared. That's all we're gonna do. Okay. Does that make sense? So on the way until whatever power we have. If it was a cube, you would go up until 3. So it's a 2, so you go 1, 2. Right? Technically, there is an invisible 1 here that does not need to be written. Okay. Any questions on the setup? Because just doing this on the exam is at least half the points. Showing me the correct setup, it means a lot. And then the annoying part is going to be the algebra, right? Okay. Any questions so far? Okay. Step 2 then. Cancel all fractions. So we need to solve for AB. This is the procedure. Multiplied by the LCD on both sides. So x minus 4 times x minus 4 So this time I'm gonna try to save some space by changing the notation a little bit. You guys understand that if I put this in parentheses, I am technically multiplying the whole thing, right? Or each term. Before I've been putting it on every single one because it's easier to see, but this is easier to write. You guys cool with this? Still with me, right? So both sides got this multiplied on it. And of course, every single time, I mean, after a while, I stopped showing this left side, or at least when I'm doing it, because it's always going to be just the numerator on the left side. Nothing else will be left. Then multiply each one, right? So I'm going to go ahead and show it. Okay. So this will be gone. One of these will be gone. So we're left with 4x equal to a times x minus 4 plus b. Okay. Any questions on the setup? That fractions are canceled. Step 2, clear? All right. Multiply and what do we call it? I forget what we said. Collect like terms, I think. And don't be afraid of stopping at any point. If you need me to repeat something, or if you missed it or you got distracted, because I space out all the time. That's a big problem for me. So let me know. No big deal. Okay, so distribute. And then collect the terms. Actually, it's already collected. There's only one x term, right? And these are the constants. So we don't have to go any further. At this point, we should just equate the coefficients and create the system. Step 4, equate the coefficients. All right. Notice that there's only one x term, right? So that means that a will be equal to what? Because there's no other ones. Yeah, it has to be 4. So we automatically get 4. Then we look at the constants. Right, that's the constants. Do we have any constants on the left? It has to be equal to 0, right? Okay. So at this point, you could create a matrix if you wanted to, but this is kind of easy to solve. So that's up to you, really. The matrix form would be 1, 0. So there's no b, right? There's an a. There's one a, so 1. No b, 0, equal to 4. There is a negative 4a. There's 1b, and equal to 0. Okay, so at that point you could solve it, or you could just solve it yourself here. If a is 4, then this would be -4 times 4 plus b equal to 0. -16 plus b is equal to 0. This pen skipping. So what does b have to be? Well, you can kind of see it, right? Yeah, b has to be 16. So you don't really have to do the matrix, but you could. You could. If you use your calculator or an online solver, you would get 1, 0, 4, 0, 1, 16. Okay. So then you just plug that into here, to the top. So the answer will be, right, 4x over x minus 4 equal to 4 over x minus 4 plus 16 over x minus 4 squared. The 84 app, you can, but not on, you can't use your phones on exams. It's the only issue. Okay, let's double check everything. Yours was wrong, Raymond?
Yeah.
Did you have the same numbers?
I have the exact same answer.
No, I mean, was your question exactly the same?
Oh, yeah, it was 4x over open parentheses x minus 4 close parentheses squared.
No, let's see what's going on here. Double check everything. 16 b should be b. The multiplication was good. The b was by itself. The system is fine. Okay. All right, well, let me punch it in and see what happens. I think it looks good. All right, write the partial fraction decomposition. Check the result algebraically. Okay. 4 x minus 4 plus 16 over x minus 4 squared. Can I? We're just gonna go. 1 second. Yeah, it's good. Maybe you plug it in strange.
No, I think it's because I put the 4x over open parentheses x minus 4 close parentheses squared equals that. I think I put
Oh,
everything instead of just the answer.
yeah, I guess they just wanted the other part.
Okay.
Technically, like on what we wrote was the complete answer.
Yeah, because that's what I wrote for the answer.
I see. Okay. Alrighty. Well, 13 is the same, so I'm gonna leave that to you guys. Is there any other general questions? Is the partial fraction making sense? Do you see the general idea? Okay. Give me a second. Okay. All right, I'm gonna move on to chapter 6. I'll leave some time after the next section to talk about more homework problems, and maybe we can do something together, but we do gotta move on. Okay, so 6.1 is the first one. So yeah, we'll start 6.1. Then I open up the homework too. Also, what I try to do, because sometimes there's a lot of really weird questions in the homework that I think are too ridiculous. I usually delete them. But if you see one that seems insane, let me know. I'll get rid of it. I'll get rid of that question. I do miss one sometimes. All right, 6.1 is where pre-cal actually starts, trigonometry. So angles, arc length, and circular motion. So we'll briefly go over this and then we'll look at the homework and see what's going on. Okay. So the first thing you need to know is like how angles are measured, how to find them, what is a negative angle, what is a positive angle. So let's talk about that first. Okay. Let's see here. Let me draw you a picture. So usually, or pretty much all the time, the initial side where your angle starts will be here. Okay. If the angle goes in this direction, counterclockwise, some theta measurement, theta degrees or radians, some theta distance, I guess, for now, from the initial side to the, we're going to call this the terminal side. Okay, so if we're going in this direction, this is considered to be a positive angle. Counterclockwise. Okay. Okay, now if our initial side is over here, again, usually the same location, but our angle is going in this direction. Some theta distance. This is going to be a negative angle. I know it's kind of weird, but that's how it is. Clockwise is negative. Okay. Now one more note for the quadrant or the 4 quadrants. I'm sure you're already familiar, but just so you remember. So if you have the X and Y plane, we know that this side right here, the first quadrant, is considered to be positive for the X, right? And positive for the Y. Quadrant 2, we know that the X becomes negative and the Y stays positive because we're still up top, above the 0. Okay, this is just a quick review. If you don't remember, let me know. All right, this is quadrant 1. Again, this is not clockwise, right? Counter. 1, 2, 3, 4. The third quadrant, everything is negative. Fourth quadrant, the y is negative. So this is plus, minus, plus, plus, minus, plus, minus, minus, plus, minus. Okay. You guys remember, right? All right, let's keep going. Some notes you're going to need for conversions from that first homework. I'm going to give you all the formulas first, just so you have them. 1 degree is equal to 60 minutes, which implies that that is equal to 1 over 60 degrees. So I'm sorry, this implies that 1 over 60 degrees is equal to 1 minute. Okay, so we're going to need all this. Now, 1 minute, we know is also equal to 60 seconds, right? So that implies that 1 over 60 minutes is equal to 1 second. So we're going to need all these conversions. We will use this for the degrees, minutes, seconds problems. Okay. So that's the first note. Arc length. Here's the definition. So for a circle, of radius r and a central angle of theta radians. Remember, we're going to use the Greek letter theta for angle measurements pretty much all the time. Pre-cal likes to reserve a lot of Greek letters for angles. We'll probably use alpha, beta, and gamma, but mainly theta, lowercase theta. Anyway, central angle of theta radians subtends an arc whose length is S equal to R theta. Okay, so on a test question or homework question, if they ask you to find arc length, your angle needs to be in radians. It cannot be in degrees. So you're gonna have to convert that. Okay, and arc length visually, all that is, right? So if I have an angle going out here, this little circular distance, this arc, is S. Okay, that's what this S is. So to find that little distance on a homework question or whatever, multiply the radius times your angle, but do not use degrees. It's going to be wrong if you do. Okay. Same thing for area of sectors. Degrees is kind of like it's not a true measurement. We should be using radians. Okay. And for those conversions that we're going to need, we should know that 1 revolution is equal to 2 pi radians. So 360 degrees is the same as 2 pi. So keep that in mind because that will help us define these conversions. So that means that 180 degrees is equal to pi radians. Which will then in turn mean that 1 degree is pi over 180. So you can solve for all of these here, but you don't have to. I'm going to do it for you. These will be our conversion stuff. Okay. We'll talk about that more in a little bit. So right now I'm just giving you all the information to start solving problems. Okay. I like to start with the formulas so you have them all in one place. Okay. So when you're converting, I guess I can make a little note here. Let me see if that comes up yet. Degrees to radians. If you want to convert from degrees to radians, use this guy. If you want to convert from radians to degrees, let me double check that. Yeah. Use this one. Okay. They're just reciprocals of each other, right? So if you want to cancel degrees, it needs to be in the bottom. So think back to like chemistry. Do you remember all those little conversions you would do? Milliliters to ounces to whatever. It's the same thing. This will be like just, except you're only doing one little fraction, nothing complex. All right. One more note, and then we'll get to the examples and the homework for 6-1. Any questions or comments on this first page? Okay, you guys cool? I turn the page. There is no rush. So let me know. Okay. So one more note, and then we'll start the homework. Area of a sector. So easiest way to picture that is, what's the area of like a little slice of a pie chart, right? If you cut out a little slice, what is the area of that piece? Well, that'll be this formula. The area A of the sector of a circle of radius r formed by a central angle of theta radians. So again, make sure it is in radians, because the homework is not going to always be in radians. Neither is the exam. It'll be whatever. You need to change it to radians if it's not already. So this will be equal to 1/2 r squared theta. So this gives you the area of this slice. Okay, so example 1. So first thing we need to know, I need to make sure you know how to do, is how to go to radians to degrees or degrees to radians. I need to make sure you're comfortable. So let's do that for the first 2 examples, okay? It's really quick. Convert the angle in degrees 2 radians. Okay, so here's an angle in degrees. So I look at the formula I gave you. You need to use the one with degrees at the bottom and multiply. That's all you have to do. So they give you the angle, and you multiply by this conversion factor. That's it. So degrees will cancel. So you're going to get 45 degrees pi over 180 degrees. So the degrees will be gone. So we are now in radians. But we got to reduce this fraction. How many 45s go into 180?
4.
4, right? Because this is technically what, 290s or 445s, yeah. So 4 times 45 is 180, right? So these will cancel. So this is the radian form of this 45-degree angle. Okay. Any questions on conversion? Okay. Example 2. And there's no rush, so just let me know if you need to slow down or something. Convert the angle in radians to degrees. So let's go the other direction. And actually, I'll do that in a second. So they give us pi over 2. So multiply by the reciprocal of this guy, right? Because I want to cancel the pi and get to degrees. So you multiply by 180 over pi. See how it's just the reciprocal, right? These pi's will cancel. We can do it in the next step. These are gone. So what is 180 divided by 2?
90.
Yeah, it has to be in degrees, 90 degrees. So nothing too crazy, right? As you can see, this section is a lot more chill compared to the last one. That's just how this class starts. Okay, wait a second. Let me give you the unit circle that you're going to need. So I'm throwing in the chat box some files that you should save. Unit circle was be needed in chapter 6. Trigonometries will be useful throughout the whole semester. And in case you missed the partial fractions last time, here they are. Okay. Let me show you how the circle works real quick, if you're not familiar. 45 degrees, as we can see, is the same as pi over 4, right? So we didn't really need to convert it because it is a common angle that's on the circle, but we should know how to do it because they're not always going to be pretty angles. Pi over 2, as we can see, is 90 degrees, which is what we've found. So this circle tells you what the radians and degrees are for the common angles. Now, later we're going to use the coordinates for sine and cosine. So we'll be using this the whole semester. So I say either print it out, use it on your exams if you want, or if you want to memorize it, that's up to you. Or write it on a formula sheet, but I say just print it and use it for your tests. I'll keep bringing that up through the examples. All right, any questions on example 1 and 2? Let me open the homework. Okay. You know, maybe it's better if I use the other link. One moment. 6. Okay, here we go. Okay. Open the instructor version for the homework so we can see the answers better. So the first 9 or so questions are just theory, about talking about formulas and concepts. So I'll leave that to you to look over. Question 10 starts to ask you about what quadrant we're in. So the unit circle will be helpful here. So look at number 10, 120 degrees. Which quadrant is it in, right? So well, look at the, let's look at the circle. Apparently I lost. 120, right? Remember that this over here. That this right here is quadrant 1, right? Quadrant 2, 3, right? Now, 120 degrees is over here. So obviously the answer is quadrant 2. So remember, counterclockwise, right? 1, 2, 3, 4. Don't forget. So that's all they're testing you there on that question. All they want to know is, can you tell which quadrant? So look at 335 and do the same. Okay. Righty. Number 11 talks about standard position. So 30 degrees, remember we said you start on this initial side. And if it's positive, then it will go in this direction, right? That's the first thing we said in the beginning of 6.1. This is going in the, if you look at answer B, can you notice, can you tell if this is a positive or negative angle? Is this positive or negative? Yeah, it's going to be negative, right? So clearly, if we're going clockwise, right, negative. If we're going counterclockwise, positive. So this question will automatically rule out these two, right? Because they're going in the negative direction. So there's no way it could be a positive 30. So you just have to look at these two. 30 is in quadrant 1. This is already in quadrant 2. So it has to be this one. It has to be A, right? So these are just testing those first concepts. Do you know what a positive angle is, a negative angle? Do you know where it starts, where it ends? That type of question. This type of ideas. Okay. So yeah, this one talks about negative. Excuse me. A little under the weather today. All right, so negative 90. I'll let you do that one. 390 though, that's interesting. That's bigger than 360, right? So that means I went all the way around and then 30 more, correct? So let's look at our circle that I sent you. So this is starting at 0. Over here, I hit 180. I go all the way back to where I started, 360. So 390 would be here, right? Does that make sense? Do you see that 390 is equivalent to 30 degrees? Because you can just keep going around forever. So if your angle is bigger than 360, subtract 360 and see what the correct angle is. Okay. Back to the question. 390 is going to have to be this one, right? Because this is negative, negative. That one's way too big. Has to be A again. Is there any questions on that idea? That makes sense? So when that happens, when you have two different angles that ends up at the same place, that is called coterminal. Okay, so 390 is coterminal to 30 degrees because you end up at the same place. Okay, so question 14, they're going to ask you, give two coterminal angles that are equivalent to this one. So basically, just give two angles that end up at the exact same place. That's all you got to do. So obviously, we just showed you, right? If I add 360 to this angle, I'll just go around one more time and land there again, right? So if I'm at 120 and I add 360, I'm back there again. So that's why they got this answer, the 480, because they just added another revolution. You can also subtract 360 and go the other direction. That's how they got the negative 240. So you can go in two different directions. You can just add 360 twice if you wanted to. You could add 360 one more time to the 480 and get a third angle if you wanted to. There's technically, you can do that forever. You can have an infinite number of coterminal angles because you can go around the circle as much as you want. Does that make sense? But just keep it simple. Coterminal angles means you have two different measurements that get you to the same place. That's it. Two different angles. Okay. I'm hoping that helps the basic stuff. You have any questions on those concepts or ideas? Remember, that's what you're here for, is to ask questions. So don't be afraid to ask me any questions. Okay, I'm going to do 15 or something similar to it because this is a harder one. If you're cool with the basics, then we'll move on. We need to convert. So this is what I was talking about earlier, decimal degree form. Degrees, minutes, seconds. They want us to change this measurement into just degrees. Okay, that's what we're going to do. Okay. I think this is example 3 now. Convert an angle to decimal. So if you have, let's say, 36 degrees, 13 minutes, 56 seconds, can you change that into a basic just degrees type of problem. Okay. So what we're going to need is those formulas I give you in the notes. 1 second is equal to 1/60 degrees. One second is equal to 1/3600 degrees. So treat this like addition. Like for example, when someone says 3 inches and 1/4, that means 3 inches plus a 1/4 inch, right? 3 1/8 or whatever. Same thing here. Just pretend that this is plus. Okay. Actually, let's take a short break here. It's 12:40. Let's take a 10-minute break because I know it's a long class. So come back about 12:50. Okay. Let me pause it. Okay. So this is saying 13 minutes, 56 seconds. We know that a minute is 1/60 degrees. So this is what we're going to do. Think of this as 13 times 1 minute, because it's technically true, right? Plus 56 times 1 second. Then you just plug this stuff in there and you'll be good for the most part. So these are all equal. So it'll be plus 13 times 1/60 degrees. One over 60 degrees plus 56 times 1/3600 degrees. So we're trying to get to degrees, so change everything into degrees. Okay. So at this point, we should use a calculator of some sort. Don't have one on me. Let's see. Let me go get one. 1 second. All right. That means a 36 Pro. It doesn't really matter. Okay. Yeah, see this okay? Looks blurry on my side. It's better. Okay. So we have 13 times 1/60. That is the same as 13/60, right? Now we have a decimal. So we're going to have to use a decimal to get to from going from degrees, minutes, seconds. We're going to have to use it. It's going to have to be in decimals. So let's plug that in right here. Plus 0.216667, right? Who cares? Plus, now do the other one. That'll be 56 divided by 3,600. So we'll just add that piece. I haven't decided how much to round to yet, but we'll figure it out. Keeps on going forever. I'll stop it there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so I have 6 decimal places. add them all together. But we should be rounding a little bit. I believe the homework question will tell us probably 2 decimal places. So let's go ahead and add these together. They can select that guy plus this guy. Let's add the fractions for me. So this calculator can do fractions for you and convert degrees to, or sorry, convert decimals to fractions or fractions to decimals if you want to. Okay, so we get 36 degrees plus 0.23, and then it has a bunch of 2's forever. Somewhere around to 2 decimal places. I think this is good enough. Okay. I think we could have just stopped. So basically, if you want to do this a little shorter, you could have done 36 plus 13 over 60 plus 56 over 3600, and then round to 2 decimals, and that'll be your answer. Okay, so once you plugged all this in, just add it all together at the same time, and you can skip to here. It's whatever. Any questions on how to go from degrees of minutes, seconds to degrees? Let me know. Let's go the other direction then. You guys are okay on that? Example 3. Okay, that's how it's always going to be. Just remember, switch out the minutes for 1 over 60 degrees. Switch out your seconds for 1 over 3600 degrees. After that, you're just adding fractions. Nothing crazy. Just remember the process and have these handy. Excuse me. Okay. This time, let's go from the decimal angle to degrees, minutes, seconds. Oh. Convert the angle to degrees, minutes, seconds. Okay. So this is a little harder, but it's not too bad, but they're going to give you something like this. 694, yeah. 53.694 degrees. We're going to have to use these formulas, so have these handy whenever you do these. I gave them to you earlier, but I'm going to write them again. Okay. So 1 degree is 60 minutes. 1 minute is 60 seconds. Okay. So what you're going to do is basically break off the decimal piece and focus on this decimal part. We're not going to deal with the 53 because remember, the D is already there, right? The 53 will be this part. We just need to convert the decimal portion into minutes and seconds. So that's basically what this is. Whenever you see this measurement here, the minutes and seconds is your decimal portion, which is 0.23. So now change the 0.23 into this is what we're going to do. Okay, that's what basically what's going to happen here. So what you do is just add it like this, because it's the same thing, right? whole number plus a decimal is exactly this, correct? So focus on this piece now. Okay. So plus 0.694. So change the degrees into 60 minutes. Let me show one extra step just in case. Sorry. So ugly. So do you agree that 0.694 degrees is the same as 0.694 times 1 degree? That's the same thing, right? So we're going to plug in like we did the last example. Plug in the 1 degree for 60 minutes. Here. We're not messing with that 53 at all. I'm just going to come along for the ride the whole time. Just don't even worry about this. So this will become 0.694 times 60 minutes. So multiply it. Point 694 times 60. 41.64. So on the next step, what you're going to do is add the 41.64 minutes. Okay. So far, you guys still with me, right? So now notice we have another decimal piece. So now focus on this piece and convert that to seconds, because technically this is 0.64 minutes. So that should really be in seconds, right? You don't say stuff like, I'll be there. And well, I guess you do, but it makes more sense to convert, right? You could say, I'll be there in 0.64 minutes, but it's kind of weird. But you could just convert that into, I don't know, 30 something seconds. But let's do that. So now what you're going to do is ignore the whole number, right? That minutes right there, and deal with the 0.64. So this is going to be 0.64, and just like before, times 1 minute. Okay. So this becomes 60 seconds. Okay, so what is 60 times 0.64? So this will become 53 degrees plus 41 minutes plus 38.4 seconds. So at this point, you're going to have to round. So you're going to cut off that 0.4 because this is now fractions of a second. So change this into 53 degrees, 41 minutes, 38 seconds. So now we're in that other form, DMS. So that's how you go from one way to the other. Any questions on the process? Can you go from this form to degrees or from degrees to this form? I did both of them for you, hoping you'll be good. Any other questions on conversions? Okay. So what are we doing? So that's 15 and 16. I'll let you guys figure those out. Now, complements and supplements. I didn't write down those definitions, although you have seen that. As you should have seen this in either middle school, elementary, or in high school. It's come up many, many times over and over again. But I do forget sometimes myself, like which one is which. So let's talk about it real quick. Do you remember what a complement of an angle is? If they ask for the complement of 12 degrees, it's gonna, what that means is, what is the other angle missing to sum up to 90? So 12 plus something is 90. So two complement angles will add up to 90. So 12 plus 78, as you can see, would be equal to 90, right? Supplement definition is the two angles will add up to 180. So that's all you need to know is like complement is that they sum up to 90, supplement is 180. That's all you have to do. Yes. Yes, Benjamin. Yeah, just like that. Excuse me. Check out 13, I think, or 18. This is already bigger than 90, so there's no way you will have a complement, right? You can't add, so it has to be sum. You can't subtract. So 105 plus a positive angle will never be 90 because it's already too big. So just remember those two definitions, and if you forget, just look it up or ask me. Complement is 90, supplement 180. Okay. Don't forget. Alrighty. Determine the quadrant. Okay. Here they talk about quadrants, which we've already talked about. Coterminal, again, we've said all that means is another angle represented by a different measurement. The same angle represented by a different measurement. So the only difference here is that they're no longer using degrees. You notice that? The last example we had degrees up here. Right? We talked about this one with the coterminal. We said if you have an angle and you add 360, you get another one. You get a coterminal angle. You subtract 360, you get another coterminal angle. Now, over here, they are no longer using degrees. So you would say plus 2 pi, minus 2 pi, because 2 pi is the same as 360, right? So for this question, you say, all right, well, if I have pi over 4 and I add 2 pi, that'll give me this answer. Okay. Now, in your calculator, let's see if we can do it. I don't remember. I mean, I think you should be able to do the fractions because you need to know it. But if you do it with fractions, the LCD is 4, right? So I need to multiply this by 4 on top and bottom, which will get me 8 pi over 4. So 1 plus 8 is 9. That's how they got this answer. Right, they're just adding fractions. So to get one of them, you add by 2 pi. To get the other, you subtract by 2 pi. Okay, that's all they did to get coterminals for measurement or for angles in radians instead of degrees. Okay, nothing crazy. It's not working again. There it goes. Okay, so if you were to do this on your calculator, I think you can do radians or you can ignore the pi, but let's see. Pi over 4 plus 2 pi. If I want that in fraction, let's see where that button is. Math. Nope. Someone draw out a class there. Well, it should be able to do it, but it'll get us degrees, minutes, seconds in here. That's cool. It could be useful. Anyway, if you wanted to check your work, you could just say, instead of adding that pi in there, you could just say, you know what, that's technically 1/4 plus 2, right? And then change to press math button number 1, changes to a fraction. I don't want a mixed number though. So I'm going to do that again. Enter. Second. And then there's this button above the enter button right here. 9/4. So we had 9 pi fourths as our answer, right? So technically you can just add them without the pi symbol and just keep in mind that it's technically there, right? If you want to check your fraction work. Although I prefer that you're comfortable adding fractions, you should be able to add stuff like this, right? Pi fourths plus 2 pi. But anyway, just giving you tips if you need them. Over here is the same question, but again, they're using radians. So same type of deal. Here they want us to convert, which we already did. Okay, here they're converting a negative angle, same stuff. I think we've covered everything in this section, except this last thing here. Okay. So let's finish up this section here. And also let me delete some of these. I don't like this one. It looks hard. Might delete this. times 2. Let's see. Yeah. I'm gonna turn the page. You guys are cool on this page? Okay. Let's find 6-1 and then we'll move on to 6-2. Oh, center position means you're just going in the positive direction. Okay. So let's do arc length and area. We haven't talked about that. I gave you all those formulas earlier. Find the length. S and area A. Yeah. Okay. That's my really crappy circle there. I'm sorry. Looks like a potato. Oh man, you guys see those guys on YouTube and they make perfect circles on the chalkboard? Yeah, I don't have those skills at all, but they're impressive. Okay, so this is some sector. So I'm going this direction, some theta degrees. Theta is equal to pi over 4. R is equal to 2 feet. So since theta is in radians, we can use both formulas right away, right? There's nothing stopping us here. So S is the arc length. I should have said arc. So S will be equal to R times theta, which is 2 feet times pi over 4. So this will become pi over 2 feet. Now, radians is considered to be a unitless measure. So when you multiply it times feet, it's going to be in feet. It doesn't switch to feet radians. You know what I'm saying? Like, it doesn't change whatever unit you're dealing with. And that's why we have to do radians, because if you try to use degrees, that is not unitless. It's a unit that we made up to understand angles easier, but radians is more proper and way better for calculations and like physics, engineering and stuff. So you want to try to get away from degrees as much as you can. You start doing like actual science type of stuff. You don't want to use degrees. Anyway, so pi over 2, what is that as a decimal? This sounds weird to say pi over 2 feet, right? What the hell is it? So it's about 1.57 feet. So approximate symbol. $1.57 feet. I remember in graduate school, one of my classmates trying to use degrees, and the professor just made fun of him the whole time. It's like you've been in math for 10 years already. Why are you using degrees, bro? It's like, I thought that was really mean, but eventually, I guess it's weird to use them if you're in advanced math. I guess if you're in a like PhD level and you're still talking about degrees, I guess they will tease you a bit. But, people are weird. Any questions on the first piece here? You see how as long as it's in radians, we're good, right? So one thing I need you to know is be careful and use the correct measurements when you get there. So if we're doing area, what do you expect the units to be? So the formula is 1/2 r squared theta. R is 2 feet. So if you're squaring the radius, what happens to feet? How do you measure area? This in real life. Like if you're looking at an apartment or a house and they tell you the footage of the property, what do they use? Right? It's always square feet, right? It has to be square feet because it's a measurement of area. It's not distance. So whenever you're dealing with area, there will always be squared something, squared units. Okay. So that's something that we all technically know. I'm sure we've all looked at apartments or something at some point, or measured your own room. So it's a two-dimensional measurement, therefore squared. 2 feet squared would be 4 feet squared, right? So since we're multiplying by radians, the final measurement will be feet squared. So what is 1/2 of 4 times pi over 4? Looks like it's going to be the same, except in squared units. That's interesting. That never happens. This is just a very rare, specific example. Okay. See how this is 1 pi half feet? This is pi half feet squared. Not the same. This is a distance measurement. This is a area measurement. And if we're talking about volume, we all know that that's going to be 3-dimensional, right? Cubic. I know we don't always think about it that way, but that's what's happening. So make sure you put the proper units. Any questions on finding arc length and what it is, or the area of a sector? I forgot to put sector. All right, so let's move on. Let's talk about, I guess there's one note I didn't mention, linear speed. The definition of linear speed suppose that an object moves on a circle of radius r at a constant speed s. Well, hold on a second. Hold on a second. We missed something here. Constant speed. Yeah, okay. If s is the distance if s is the distance traveled in time t on this circle, then the linear speed v of the object is v equal to s over t. So this is the formula you're going to need. So s is still going to be what we found earlier using the arc length. Okay. So if they ask for linear speed, we're going to have to first find the arc length. So I guess picture this as if you're going around a circle, this would be the speed on the edge of the circle. Okay, that is what the linear speed is. Okay, because it's the arc length over time. Does that make sense? So like, I don't know, if you picture a wind turbine, right? If I'm spinning the wind turbine, the speed at the edge of the blade, that would be the linear speed. That is different from the speed of the turbine spinning. Those are two different things. Okay. I know that sounds strange, but the speed at different parts of the blade would be different. Okay, so the speed of the actual turbine spinning, the entire thing, would be called the angular speed. I think of visual, or think of it, think of it that way. I think it helps to visualize what is the difference. So angular speed is the entire thing spinning. The angular speed W of an object is the angle theta swept out divided by the elapsed time. So they usually use omega or W for angular speed. So it's the speed of the angle itself turning. So the speed of the turn versus the speed of the edge. Okay. Do you understand the difference between linear and angular? Okay, so over here, you basically have some sector, right? So how fast are you going around the circle? Okay. From versus how fast is the circle turning? Those are two things. It's kind of hard to draw. I'm hoping that makes sense. Any questions on that? Give me 1 second. Okay. Let's try an example where they ask us to find the angular speed. In just a moment. Let's see, I think that was good. I'll get rid of this one maybe. Okay. Trying to remove some of the homework problems that are difficult. One last example for 6.1. You guys cool if I turn the page? Okay. Let me know. All right, is example 6. Oh, I got it. 6. So example 6. All right. So a 6 1/4 inch circular saw rotates at 4,300 RPMs. They want us to round to 2 decimal places. So it's similar to one of your homework questions. 2 decimal places. So part A. Find the angular speed in feet per minute. Okay. So what is angular speed again? No, we said, let's see here. Yeah, the theta over time, right? So we're gonna have to convert the RPMs into a type of angle. And then we had to convert it into minutes because they said feet per minute. All right. So first of all, what is an RPM? I mean, we hear that all the time in our car, right? What the heck is that?
Rotations per minute.
So it's rotation per minute. Okay, so we know rotation is 360, right? One rotation, or 2 pi. So we're gonna have to convert rotation into 2 pi radians per minute. So, okay, so let's think about this. So omega, when you get that angle, is equal to theta over time. So the theta is going to be, we have to get it out of the RPMs. So it's going to be 4,300 times 2 pi radians per 1 minute. Do you see where this came from? Right? 2 pi is a revolution. Per means over 1 minute. Right? When they say 60 miles per hour, that means 60 miles divided an hour. Any questions on that setup? Because that's really the most of the work right there. So multiply that up and we'll have radians per minute. The only issue was they said feet. Find English. 43 per minute. Theta. Well, no, I think that's fine. Sorry, I'm overthinking that. All right, let's multiply it out. So 4,300 times 2 pi. Okay. I'm forgetting something. Rotates. Theta over minutes. Yeah, I think it's fine. Something's just bugging me. If we change that into decimal, 8,600 times pi. Ugh. I need you to change. I do not want it in exact notation. Weird. 1 second. Just to save time here. Let me use this guy. So 8,600 times pi. So that should be our answer on top. Rounded to 2 decimal places, that's going to be 0.70. So approximately 27,017.70 rads or radians per minute. I think the next question needs to be in feet per minute, but angular speed is a measurement of the angle. So it should be in radians, not feet. So I think I should not have written this. That doesn't make sense. Part B. Any question on part A? Because we got angle over time, radians over minute. So we're good. Part B, find the linear speed. So this one is in feet per minute. So this is the speed around the buzzsaw, the circular saw. Right, so if you're right on the blade, right on the edge, the speed on that edge is the linear speed. The speed of the blade spinning in circles is going to be this one, the omega, which is what the 4,300 RPMs is, right? This is the speed of the blade spinning. This is in a different measurement of radians per minute, okay? Instead of just revolutions. Only difference. So we're gonna have to find the S, because V is equal to S over T, right? The arc length over time. That'll be R theta over time. What do you think the radius is? Now we have the theta up right here, don't we? So that part's technically done. We have theta. We did it up here. But what is R in this question? Right, they tell us it's a 6¼ inch circular saw. So that's the size of the blade, the circle saw. So those are usually measured across the blade. So this is a diameter measurement, right? 6¼ So we're going to divide the 6¼ by 2. Does that make sense? Because that's your diameter. We need the radius because we know that the radius is half the diameter. So right here we will add 6.25 inches over 2. That's my radius. Times 4,300 times 2 pi. That's what we found to be our theta earlier. Per minute, because that's the speed of revolution. So now you see that when we're finished, we're going to have inches per minute, right? because radians are unitless. But they want feet. So we're gonna have to convert it from inches to feet, either now or at the end, doesn't matter. But any questions on the setup? Do you see why this is set up this way? Okay, so no questions on R or theta or time, right? So multiply all this garbage out. You should get about just, yeah, at this point, just punch into your calculator. You should get 84. Something 6.25 divided by 2 times 4,300 times 2 times pi divided by 1, which we don't have to do. I forgot to put it in engineering. Dang it. It'll be 84,430.30. Let's do 0.30 for 2 decimal places. Inches per minute. Now, have you guys taken chemistry? Do you remember conversions in chemistry, or what other class do you do that in? You do it in cooking classes too, technically. But whenever you do any kind of conversion, doesn't matter what topic, either physics, chemistry, whatever, you multiply by a fraction. That's it. It's called the conversion factor. So how many inches are in a feet, in a foot? And that's the conversion factor. So if I want to go to feet, you put the feet on top. So 1 foot is, for every foot you have 12 inches, right? That's something you already know. But this is what you need to write it. You have to write it this way. Feet per inches. So this is your conversion factor. Just like earlier, we're multiplying by a fraction to cancel degrees to get to radians. Same thing. So inches will cancel. So now I have feet. So 84,430.3 feet divided by 12 will get me my answer. So our answer will be 7,035.86 feet per minute. So that's how fast the blade is spinning in feet per minute. I'm sorry, that's how fast the edge is going, blade. So if you have if you're looking at one single tooth on the blade, that's how fast it's going around. Part A was how fast it was spinning. Do you see the difference? So like when you look at a wind turbine, it looks like they're going slow, right, from far away. But if you were to measure the speed of that edge of the blade, it would be very fast, even though the rotation appears to be slow. And also, looks misleading because it's far away too, but the edge will always be way faster. Okay. Anyway. Any questions on 6-1? That's pretty much everything you need to worry about. I try to do one of each type of homework problem. Any questions on that? On any of these ideas? Okay. Let's look at our schedule again. We just did 6-1. Thursday, tomorrow we're probably gonna do, I'm gonna try to do all 4 of these, but we'll see how that goes. But for sure, we're gonna do 2 sections. Okay, so I know 9-4 is, there's a lot there. Try your best to get it done as soon as you can. The rule of thumb is try to get the section we just talked about done before I see you again, or at least mostly done or have started, so you have questions. Okay, but I know that can be difficult. Now for the last, I want to use the last 30 minutes or so to, I want you to work on your homework and ask me some questions. And I need to figure out what's going on with Alexander, your homework's still being weird, right? I need to figure that out. So this next 30 minutes we have till, let me see. Technically, we have to 2:35. So I want you to stay here and work on your homework, but just take a 10-minute break and then start, because it's best to do it right away because we just talked about it. It's still fresh in your mind. If you take a break, you'll start to forget what we talked about. It makes more sense to start right away. Okay. So please take a short break and start your homework. And I'll be taking roll towards the end. I'll be right back. I'm going to send the yesterday's notes too.